This is section 7.3. We're going to use similar right triangles. Here's theorem 7.5. It tells you if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. So here's a right triangle. Triangle ABC is a big right triangle. Now you can also draw this segment down to the hypotenuse. This is called the altitude to the hypotenuse of a right triangle because it's perpendicular to one of the sides and it does act as the altitude of this triangle. Since it's touching the hypotenuse, we call it the altitude to the hypotenuse. So notice what this segment CD does. That's the altitude to the hypotenuse. It breaks this big right triangle into a smaller right triangle and then a triangle that's even smaller than that that's also a right triangle. So what you end up with is this big black right triangle, triangle ABC, and then you have this smaller right triangle, we're calling it triangle ADC, and I pulled it out and made it red. Also, you have triangle CDB over here that I made blue, which is also a right triangle. So when this altitude to the hypotenuse is drawn on a right triangle, what happens is you get three right triangles and they're all similar to each other. So obviously you're going to need to remember things about similar triangles. This is a very useful exercise that we're going to do here. We're going to identify the similar triangles in this diagram. We're going to sketch the three similar triangles so that the corresponding angles and sides have the same orientation. This is going to be really useful. So here's our big right triangle. Generally what I do when I draw my triangles is I'll draw my small right triangle. I'll draw my medium right triangle. And I'll draw my big right triangle. So what I'm doing is I'm separating them, and notice how I'm kind of orientating them the same way, where I have my short leg on the bottom, my longer leg on the left side, and then my hypotenuse on the right side. Now I need to label these. So for example, in the big right triangle, the right angle is T, and the short leg is segment TS. So the long leg is segment TR. The medium right triangle, that's this guy right here. This is a right angle also. So the right angle is U. The short leg is actually the altitude to the hypotenuse on the medium-sized triangle. So this is segment T, or I'm sorry, point T. This is segment UT. Your long leg is segment UR. Here's the small triangle. That's this guy right here. Notice how the right angle is at angle U. The short leg is this segment, segment US. The long leg is the altitude to the hypotenuse, segment UT. So notice how this segment is the long leg on the small triangle, but the short leg on the medium-sized right triangle. These three triangles are similar to each other. And if you put them in this orientation, it's really easy to identify what part corresponds with what. So you can say triangle TUS is similar to this triangle. Now watch the order. We did TUS on the small one. So you got to do RUT on the medium one. And then same order here, triangle RTS on the biggest one. We're going to do the same thing with these triangles, except now we're going to get some lengths in here and we're going to solve for these. We'll do that in a different video though.